Okay, let's unpack one of the really big architectural tensions we see facing tech leadership right now. This thing called the security velocity paradox.
Yeah, it's this fundamental conflict, isn't it? You've got your VP of engineering pushing hard to ship features faster, maybe seeing like a 50% speed boost from automation AI in the pipeline.
Huge gains there.
Huge gains. But, and here's the paradox, every bit of that speed seems to generate this massive increase in security alerts, audit requirements, compliance checks. It multiplies.
And that puts you, if you're the CISO or the VP engineer listening, in a really tough spot.
Yeah.
All that fantastic development speed,
Yeah.
it just evaporates the minute an auditor shows up.
Right. You slam the brakes on.
You're back to what, manual evidence gathering, taking screenshots, filling out spreadsheets, using systems built for humans, not for automated checks.
Yeah.
Just creates so much friction.
Exactly. You ship fast, then you grind to a halt. The audit itself can become the single biggest blocker to velocity.
So the mission for us in this deep dive, based on the materials we've looked at, is to explore a different approach. A way speed and assurance can actually work together.
That's it. We're looking at how systems, like the example RailGuard Insight, are built around shipping-proof, actual, signed proof, not just, promises that things are okay.
Okay, that brings up a key question right away. Where does something like this fit? Security teams, they already have tons of tools. Scanners everywhere.
Yeah, good question. And this is where RailGuard Insight, that's RailGuard, one word, positions itself quite differently. It's not aiming to be just another scanner. Think of it more as an intelligence layer, a verification layer.
An intelligence layer. How so?
Well, connecting it to the wider security world, it sort of aims to be the Switzerland of scanners. You keep your existing tools, your SAST, your DAST, your SCA.
All necessary things.
Absolutely necessary.
Okay.
RailGuard is designed to be complementary. It sits above those tools, takes their findings, standardizes them, and then, this is key, validates the whole process.
Okay, that's a critical distinction because a lot of teams are looking at ASPM right now, Application Security Posture Management. ASPM, how is this different?
It boils down to focus. ASPM tools. They're generally great for visibility, giving you that broad overview of your security posture, managing assets, centralizing tickets. They show you what you have and where the potential risks are.
Like a map of the danger zones.
A map, exactly, a high-level view. But the sources we looked at argue that just seeing the risk isn't enough when you're in a tightly regulated space.
Right. Visibility is kind of after the fact, isn't it?
Precisely. It's reporting on risk that already exists. RailGuard's approach, what they call the proof-first model, is all about generating that verifiable, cryptographically signed evidence during the build and deploy process. Proof that policies were followed, proof that risks were handled.
It's the difference between the map and maybe a signed receipt confirming you actually navigated the safe path.
Yeah, I like that. Speed with receipts. That captures it pretty well.
But let's push on that. Does adding another layer, even an intelligence layer, just add more complexity for developers? They're already juggling multiple tools.
That's a fair challenge. And it's addressed by how it delivers value directly to the engineering teams, not just compliance down the line. There are 3 main ways RailGuard Insight helps. 2 are very developer-centric.
Okay, let's take the first one. The PR security gate. What's that?
So this plugs straight into the developer's world, usually GitHub. Right in the pull request, the PR, it gives concrete, actionable guidance on how to fix a security issue it finds.
So not a separate ticket hours later.
Exactly. No waiting 24 hours for a ticket from security. The feedback is instant right there in the PR. That immediate loop is vital for keeping velocity up. Some sources even mention they're testing auto-patch suggestions in pilots.
Wow, okay. That could really cut down the back and forth.
Yeah.
Now, what about the sheer volume of alerts, that alert fatigue problem everyone talks about?
Yeah, the alert tsunami. That's the second feature, alert correlation. Every CISO feels this pain. Run 3 scanners, get 3 alerts for the same dependency, plus maybe 20 other low-priority things.
It's just noise.
A lot of it is noise. RailGuard Insight works to correlate and deduplicate those alerts coming from all the underlying scanners it integrates with.
And is there data on that from the pilots? Because reducing noise is a direct engineering win.
There is. The pilot data we saw focuses specifically on measuring that reduction, showing significant drops in duplicate alerts, grouping low-value findings by root cause. The idea is engineers only see the critical, unique stuff that needs attention. It makes the signal usable again.
Okay, that makes sense. Now, the third piece you mentioned, the proof-first model. This sounds like the core idea, the thing that generates the verifiable evidence.
Yes, this is what the sources frame as the real differentiator, the defensible moat, if you will. This model is what produces the signed proof pack. They call it a VS-bomb. That's pronounced VS-bomb.
A VS-bomb, like an
Yeah.
evolution of the S-bomb,
Yeah.
the software bill of materials.
Kind of. It builds on the S-bomb concept, the S-bomb, but it's much more. The key is that it's signed.
Why the signature? The industry's already adopting S-bombs for transparency. What does signing add?
The signature changes everything, especially in high-stakes industries. Just handing over a list of ingredients in S-bomb isn't enough proof for an auditor in, say, fintech or healthcare.
You need more assurance.
You need chain of custody. You need to know it hasn't been tampered with. You need attestation. The cryptographic signature provides that non-repudiation. It proves this specific proof pack was generated at this time by this verified process and hasn't changed since.
So it's like going from a self-declaration spreadsheet to a document that's been notarized and sealed.
Exactly that. A much stronger form of evidence.
Okay, so this VS-bomb, it bundles 5 specific things together. What are they and why those 5?
Right. The 5 components are designed to give a complete verifiable picture. First, you have the standard SBOM, the SBOM, your list of software components.
The basic ingredients list.
Yep. Second, the raw findings from all those scanners we talked about. Often, this is standardized into a format like serif, pronounced serif. This gives the auditors the full details of what tests were run and what they found.
Okay, SBOM and scanner findings. What else?
Third, the policy decisions. What rules did the security gate check? Did it pass? Were there exceptions? That context is crucial. Fourth is provenance and attestations, details about the build environment, the time, the specific steps taken, the where and when.
And the 5th must be the signature.
The 5th is the linchpin. The cryptographic signature from a trusted source, like the build system itself. Put those 5 together, and preparing for an audit shifts from, weeks of digging through logs and tickets to verifying a single signed file.
That sounds incredibly powerful, but how does an engineer or the CI/CD pipeline actually use this?
Yeah.
How is the proof generated and checked?
It needs to be seamless, right? It integrates via a command line tool called Insight TTL. That's Insight CTL. This is the main interface for developers and the pipeline. It has 2 primary functions.
Let's start with creating the proof.
Okay, so the first command is Insight TTL proof. This runs at a specific point in the CI/CD pipeline, usually right after all the security scans finish, but before the software artifact gets pushed to a registry or deployed. It pulls together those 5 components we just discussed and generates the signed VS-bomb, the proof pack.
So proof gets generated automatically as part of the build. Then how do you ensure that proof is actually checked later on? Say, when moving from dev to staging or staging to prod.
That's the job of the second command. Insight TTL Verify Pack. When the artifact moves to the next stage, you can set a policy that requires this verification step. The command checks the proof pack, the VS-bomb. It validates the signature, checks the contents against policy, makes sure it hasn't been tampered with.
And if it fails?
If verification fails, maybe the proof is missing or the signature is invalid or it shows a policy violation, the deployment halts. The principle is no proof, no ship.
That's the kind of automated gatekeeping security teams dream of. It means the CISO isn't just hoping the dev team followed procedure. There's actual, verifiable evidence generated automatically before anything moves forward. Much better than chasing spreadsheets after the fact.
Absolutely. And this need for verifiable trust, especially when moving fast, really defines who this is for. RailGuard Insight, based on the analysis, is aimed squarely at organizations juggling that high-speed development with serious regulatory pressure.
So we're talking specific sectors where getting compliance wrong is just not an option.
Exactly. Think fintech, massive pressure to innovate, but ironclad financial regulations. Think healthcare AI, patient data privacy, model integrity, FDA requirements potentially. Think autonomous systems, safety critical software. Anywhere that software failure or a compliance breach has huge consequences.
Even SaaS companies handling lots of sensitive user data, PII.
Definitely. Anywhere the audit trail needs to be robust and, frankly, automated.
Okay, let's wrap up by talking outcomes. What are the pilots actually showing? What's the tangible benefit beyond just making audits easier? Because easier audits are great, but VPs of engineering want to see efficiency too.
The reported benefits are really twofold. One is obviously establishing that defensible evidence trail we've been discussing. But the other, which is key for engineering, is measurable noise reduction.
How are they measuring that?
The pilots seem very data-driven. They establish a baseline in the first week, how many alerts, duplicates, etc. Then they track the reduction over time, day 30, day 60, day 90, specifically looking at the drop in duplicate and low-value alerts thanks to the correlation feature.
So they're demonstrating both a compliance win and the engineering efficiency win in parallel.
That seems to be the goal. To show that adopting this proof-first approach isn't just another compliance tax, it actually helps the engineering team focus by cutting out noise and speeding up fixes right in the PR.
When you put it all together, it feels like a shift. Moving security from being this necessary roadblock that involves a lot of manual work to being something built into the architecture, providing evidence at speed.
Yeah, it makes security an enabler of speed, not just a check on it, which is a pretty fundamental change.
And for anyone listening who's feeling that security velocity paradox pain right now, the sources mentioned a specific way to potentially explore this.
That's right. RailGuard Insight is apparently running a design partner pilot program. It's positioned as a limited-time opportunity for high-velocity teams to get hands-on.
Okay, so that's the call to action for you listening. What are the specifics of that pilot program?
It's described as a structured 60 to 90-day engagement. The idea is for a team to integrate the system, measure the alert noise reduction for themselves, and really validate if this proof-first model works in their environment. There's a flat fee of $10,000 to participate.
And a key detail on that fee.
Yes. Important point. That $10,000 pilot fee is fully credited towards an annual subscription if the team decides to continue after the pilot. So effectively, you're prepaying for a portion of the first year while you test it out.
Makes sense. And where can people find out more?
The resource mentioned is RailguarAI pilot. That's RailguardAI/pilot.
Great. So a final thought for everyone listening. As you think about your own team's processes, especially around audits and compliance, what really resonates with you about this potential shift, moving away from just focusing on posture and visibility towards demanding verifiable, sign-proof, automatically generated throughout your pipeline? Just imagine how much manual effort that could potentially remove.